So let's look into the idea of potential difference. So potential difference or voltage is nothing but when we do a work on 1 coulomb, getting the charge from point A to point B, this particular work, that a particular amount of energy spent is the potential difference between point A and B. Okay, so that's the definition per se, that's the idea. So potential difference is the difference in the potential energy between 2 points in an electrical field. Doing what? Working with 1 unit of or plus 1 coulomb of charge. As a definition, it's the potential difference between points A and B is defined as the amount of work required to move a unit positive charge from point A to point B against the electrostatic force. So how do you represent it? Well, VAB or delta V, so on and so forth. The quite a few representation, and this is the common one which we're going to start off with. So how does the math look like? First, let's look at the math of working with a charge Q naught, moving it from point A to B against the electrical field. We are say moving it to the left, right? We are making it move to the left. Say with a, we have a displacement of dr. So what is the work that we do for a small displacement dr? The work will be equal to the external force times of or dot product of dr. Is that correct? So we can call this as external. Now, if we move the charge from point A to B, the entire length. This is for a small displacement dr. What if we move from point A to B? How will we find the answer? Yes, to do this, we have to make use of correct integration. So the total external work that we do will be nothing but an integration of the work that we do along the way from point A to B. We need to add them up. So basically, it will be an integration of force external into dr dot product. So in all of these cases, we exert a force or we move the charge very slowly. Again, this is the entire funda for this entire chapter, so I'm teaching it slowly. You need to understand this point. We move the charge very slowly. So slowly that acceleration is almost 0 meter per second square. For this to happen, what should be the relationship between the external force and the force by electrical field? They should be almost equal. Okay, guys. In terms of magnitude, they're almost equal, but when it comes to direction, they are, yes, negative of each other. That they are in opposite direction. So with all of this in mind, the work that we do, which is nothing but your potential difference between point A and B, okay, is nothing but an integration of negative integration of the dot product between the electrical force and your displacement vector from A to B, from A to B. Okay, guys. Sorry, this is not this is not potential difference. This is not a unit charge. is the work done by external field. Now in this place, right, in this place of Q naught coulomb, if I make use of 1 coulomb of charge, that is the work done by external field, but for 1 coulomb of charge, same funda. Okay, same funda. Instead of that, I'm just doing it on 1 coulomb. How can I find 1 coulomb? Just divide with Q naught. For example, if I buy 10 apples or 10 book, right, 10 eraser, if I want to find one of it, the cost of one, what should I do? I'll divide it. As simple as that, is it not? And this idea is your potential difference. So basically, this is nothing but electrical force dotted with divided by Q naught. And what is this quantity? Think of it, pause and think, what is this quantity? Heli. Yes, so this is nothing but E, is it not? Force exerted on a unit charge is nothing but your electrical stuff. So this is nothing but minus of E and dr. And this is pretty important formula. We're pretty much going to use everywhere. So next thing, what is the SI unit? I'm sure you guys know this. Volt, named after a person. So we're going to write it as capital V as well. Either this or that. It's an or, not brackets, this or that. Then, how do you define 1 volt? Well, so we know that it's related to work and charge and all of that. So basically, if I make this as 1, this as 1 joule, and this as 1 coulomb, I'll get 1 in the left, 1 by 1, right? So how do you define it? We said to have 1 volt between 2 points. So we have point A and B, and the potential difference between A and B is said to be 1 volt if we do a work of 1 joule on 1 coulomb of charge. Does it make sense? Potential difference between points A and B is said to be 1 volt if 1 joule of work is done to move a unit positive charge from point A to point B against the electrostatic field. I think there's nothing over here. Yeah. So what is that we looked at? So we are looking at learning or understanding the strength of an electrical field with a scalar quantity known as electrical potential. It is related to energy. So in this scenario, we are looking at a positive charge, which is 1 coulomb, from infinity to point A. That gives us our electrical potential. But if we move it between 2 points which are kind of nearby and all of that, we can call it as voltage or potential difference. And when we talk about potential difference, we use VAB, delta V, and so on and so forth. So first case, we looked at moving a charge of Q naught from point A to point B. A small work of dr gives us force into displacement. That is our work. As simple as that. Right? Work is equal to force into displacement or dot product. I hope you guys remember dot product and cross product. The same funda over here as well. That will not change. Now, since we want to add from point A to point B, all the work that we do from point A to point B, what we have to do? We have to integrate it. So, integrating the force and the dr and so on and so forth, right? That is your work done by external quantity. So we do the work. This is where things get thoda confusing for many people. We do the work in such a way that the charge moves very slowly. And for this to happen, the external force and the electrical field has to be almost equal in terms of magnitude, but in terms of direction, it has to be opposite. We are doing work against the electrical field in moving a unit test charge. Now, if I want to look at just 1 coulomb of charge, what should I do? I should divide with Q naught, as simple as that. 10 apples will cost 100 rupees, 1 apple will cost 100 by 10. So similarly, we'll divide with Q naught, and what expression we get, that is your potential difference between point A and B. And you guys know how to define 1 volt, right? 10th grade syllabus again, but here too you can see the same funda. Now it's time for you guys to pause. This is the same pattern that we're going to study for all the half of the syllabus. Okay, so we're going to make use of this. So this has to be very, very clear.